Writing a logarithm in exponential form is the exact opposite process of writing a exponential term as a logarithm. Again, our focus is on the base and moving it to the right spot. So let's start out with the first example here. Log base 8 of 64 equals 2. In order to write that as an exponent, we move that 8 to the other side and make it the base of the exponential term. And what that's going to look like is you're left with your 64 on the left side, and on the right side you have your base 8 to the 2 power, to the second power. So 8 squared is equal to 64. Let's do that again. We have log base 16 of 4 is equal to 1/2. So we take our base 16 and we move that over to the other side, and that's going to leave us with 4 on the left is equal to 16 to the 1/2 power, or the square root of 16. Replicate that again here. We have log base q to the of 7 is equal to t. We take our q, we move it to the other side, and we're left with 7 equals, and then our base q to the t power. Finally, we have our nice messy example here. Log base x plus 2 of a squared plus b squared is equal to s times t. Again, we're just going to take our base, and we're going to make it the base of an exponent on the other side of the equation. So we're left with a squared plus b squared is equal to our base, x plus 2, raised to the st power. Now let's do some examples where we have to evaluate what the answer is. Now in these, you don't see it set equal to something, so there's really nothing to move over to the other side. So in problems like that, I like to set it equal to some arbitrary variable. I happen to choose x, you could use question mark, it really doesn't matter. So if I put x on the other side, and use the same process we did earlier, and you're going to take this base 10 of our logarithm and you're going to make it the base of your exponent. So that means that you're going to have 1,000 on the left side equal to 10 to the x power. Took our base, moved it there. Now, since this is a nice constant, we can actually figure out what is the answer. What is x? 10 to what power equals 1,000? Well, 10 to the third power equals 1,000, because that's how you end up getting those 3 zeros there. So if 10 to the third power is 1,000, then your answer is just going to be 3. Now, if you knew how to do that in your head immediately, you could say log base 10 of 1,000 is 3, but having this exponential step makes it something that's much more familiar. Next one has log base 2 of 8. I'm going to set it equal to x so we have something to work with. I'm going to take that base of 2, we're going to move it to the other side, and we're going to be left with 8 equal to 2 to the x power. Well, 2 to what power is 8? It's going to be, again, x equals 3. So our answer is 3. Next one, log base 9 of 3. Set it equal to x, and I move my base to the other side. So we're going to be left with 3 equals 9 to the x. 9 to what power equals 3? Well, it's going to have to be some fractional power. I know the square root of 9 is 3. And so the square root is actually the same as the 1/2 power. So the answer is going to be 1/2. 9 raised to the 1/2 power is 3. This next example, we have log base 8 of -5. Set it equal to x again. So we're going to have that base move over, and we will have -5 equals 8 to the x. Well, I don't have a clue how to do that, but you have to remember, we're saying 8 to some power is going to be a negative number. No matter how big or how small you choose x, it will never go below 0. The exponential term is always positive. Therefore, this is actually just a trick question. It's impossible. You can't do it. So whenever you see some constant set to the x power here equal to a negative, you know that it's not going to work. Finally, we have log base 8 of 1. Set it equal to x, move our exponent over, or our base, excuse me, move our base over, and we have 1 equals 8 to the x. Well, 8 to what power is going to equal 1? Anything to what power is going to equal 1? Anything to the 0 power is going to equal 1. So our answer is just 0. So whenever you have the log base anything of 1, it's just going to be 0 because anything raised to the 0 power is 1.